Hey everybody, we are going to get started with the lesson 6 notes. What I would like you to have out is your textbook, and I'd like you to open it to page 44, which is the start of lesson 6. The reason being, there's some tables and graphs and that sort of thing that I'm going to be referring to. That way we don't have to copy everything down that is in the example. We can just refer to what is in the textbook. Okay, so 1-6 notes. We are going to be talking about functions. Okay, relations and functions. A function or relation is a machine. Okay? We put things in most cases, numbers. We do something to it, and then we get an output. Okay? So, for example, let's say I have something that looks like this 1, 2, 3. We're going to call this the domain. 4, 5, 6, 7, and we're going to call this the range. All right, now I want you to draw an arrow from 1 to 5 and an arrow from 2 to 4 and another one from 2 to 7 and then an arrow from 3 to 6. Now this is an example of a mapping diagram. Okay, and what we are doing is we are relating two sets of numbers. This is a relation. The domain are the numbers that we put into the machine, and the range are the numbers that come out of the machine. Okay, so another way to write it would be as ordered pairs, like points on a graph. So ordered pairs in this case would be 1, 5. I put 1 in, I get 5 out. Another one would be 2, 4. I put 2 in, I get 4 out. If I put 2 in, I also get 7. My last ordered pair would be 3, 6. Okay, so in general, we have our X and Y pairs, or our input and output, or our domain and range. And these words are going to keep coming up again and again and again. Now, let me use some colors here. So everything in orange is all related. The inputs are the domain. They're also the X values when we write our ordered pairs. The outputs are the range. So these are all the outputs. And they are all the Y coordinates. Okay, so it's really important that all of those words go together in your brain. Okay, let's try an example here. I'd like you to look at the chart on page 44, this one right here. And what does it say to do? It says to give the domain and range for the relation shown. Give the domain and range for the relation shown. So first, let's list the ordered pairs that we have. We have 1900, the year 1900, stamps cost 2 cents. Then in 1920, they cost 2 cents. In 1940, they cost 3 cents. In 1960, cost 4 cents. 1980 cost 15 cents. And in the year 2000, cost 33 cents. Nowadays, I want to say it's like 51 cents, but I'm not entirely sure. It's getting more expensive. Okay, so the domain is all of the inputs or all of the x's. So my domain is all of the x coordinates. 1900, 1920, 1940, 1960, 1980, and 2000. So the domain is all the x values slash inputs. Okay, so these three things all go together. Domain, x values, inputs, they're all the same. Okay, the range is all of the y values or the outputs. So 2. Now, we've already listed 2, so I'm not going to list it again. Then we have 3, 4, 15, and 33. Okay. Now, I'd like you to look at the graph at the bottom of the page on page 44. And we are going to give the domain and range of the relation shown in the graph. So remember, the domain is just all the x values, and the range is all of the y values. So I'm going to pull this off to the side, but hopefully you're still looking at it on your own book. The domain, in this case, would be all of the x values. So if I start on the top left, that x value is -2, and then -1, 0, 1, 2, 3. So all the x values. The range is all the y values. And we also want to start this from smallest to greatest. So I'm going to start at the bottom point. The bottom point is a y value of -3. Then we go -2, -1, 0, 1, and 2. So that's all the y values. Okay, now let's get more specific about a function. Okay, here's an important definition. A function has exactly one output for each input. Exactly one output for each input. So put it in another way, that means that each x gets one y. Each x gets one y. So let's look at an example of something that is a function and something that is not a function. And we're going to use a mapping diagram because I think that's the easiest way to understand it. So let's say I have this. Here's my x's, here's my y's. Let's say I have the number 5, and then I have 1, 2, 3, and the 5 goes to 1, 2, and 3. This is not a function because this x, remember the rule is that each x gets one y, but this x has 3 different y's, so it breaks the rule. However, let's say I have this. X, Y. 1, 2, 3, 5. And I draw my arrows like this. This is a function because each x has one y. X as 1 goes to 5. 2 goes to 5. 3 goes to 5. So each x gets one y. All right. Let's take a look at example 2 on the bottom of page 45. It says determine whether each relation is a function. Determine whether each relation is a function. So I'm just going to copy this down real quick. Servings and cook time. Do any of you make rice or macaroni or anything at home? Okay, so the rule for a function is that each x gets one y. In this case, 2 goes to 5, 4 goes to 8, 6 goes to 10, 8 goes to 11. Yes, this is a function because each x has exactly one y. Each x has exactly one y. All right, let's try another example here. Size, price. So we're talking about shoe sizes here. Does each x have one y? Yes, it does. Even though they all have the same y, each x value only has one y value. So yes, this is a function. All right, let's talk about the vertical line test. This is used to determine whether a graph shows a function or not. So, a pass means that a vertical line crosses the graph at only one point. Fail means that the vertical line can cross the graph at more than 1 point. So let's look at a couple of examples here. Let's say I have a graph that looks like this. It's a curvy line. I'm going to put arrows on both ends. If I go through and draw a vertical line, how many times does it hit that line? Once. Let's pick another spot. Once. Another spot. Once. No matter where I draw my vertical line, it's only going to cross the graph at 1 point. So this passes, which means that this is a function. All right, let's try a different example. Here's my new graph. Now, if I draw a vertical line, boom. How many times did I hit the graph? I hit it more than once. I hit it twice. So this fails, which means that it is not a function. Not a function. All right, so example 3. Let's look at the graphs on page 46 in example 3. So I'm looking at these guys here, A and B. So it says it right there. Use the vertical line test to determine whether each relation is a function. If not, identify 2 points a vertical line would pass through. So here I just have a collection of points. But if we look closer, if I draw a vertical line through here, look at when x is 5, I have 2 points where x is 5. So this would fail the vertical line test. So this is not a function. Let's look at B. I want you to imagine drawing a vertical line anywhere through this graph. And no matter where we draw the vertical line, it's only going to cross it 1 time. So this is a function. This is a function. All right, that is it for lesson 6. Check Google Classroom to see which homework problems you're going to be working on from this lesson.